Sweet. Okay, welcome, welcome, welcome. We are about to take our notes. We are on 2.2, which is page 6. Sorry, page 7. We're on page 7 of the handout packet, 2.2 resulting vectors. We just did do now, and we just posted on Piazza. Remember, that's your big assignment, post on Piazza for today, the think, pair, share question. Now we're going to be on our notes. So let's get started. Make sure you have your notebook ready. And we're about to begin. So we learned about resulting vectors, right? So today in the do now, we learned about that. So let me just show you what resulting vectors are. So resulting vector okay, resulting vector is the sum of two or more vectors. The sum of two or more vectors. If you want to see this in formula form, we won't be using the formula yet, but in case for the ones who really like math and want to see a formula, it's basically different vectors. And how do you know if it's a vector? Well, you have to put what? You have to put an arrow on top. Now it's a vector. It was a scalar. Now it's a vector because it has arrows on top of this of the symbol, right? And it equals whatever that resulting vector is. Okay. And the R on the subscript of that V is the resultant vector. Okay, the resulting vector. Yeah. Give us a couple more seconds for that. So resulting vector is the sum of two or more, right? The sum of two or more vectors. And the formula is right here. Basically, how many vectors you have. You have to have at least two vectors, but you can have as many as you want. Add them together, and I'll tell you what that means later on. But basically, when you add them together, it creates a resulting vector. Okay? Awesome, 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 awesome. I will post these notes on Google Classroom, so if you don't get a chance to copy them, it's okay. Boom. Now let's do an example, okay? Let's do an example. I put this right here real quick. Basically, this just means that always put arrows tip to tail. What does that mean? Well, let's see. Let's make an example real quick. Let's say I have two vectors. I have vector here. Okay. And I have another vector, let's say here. Okay. So that means I have vector 1, right, plus vector 2. And what does that equal? Well, if I want to find the resultant vector, right now, I'm at tip to tail. So that means the tip of this vector is at the tail of that vector. Okay, so always do tip to tail when it comes to vectors, except when it's resulting vectors. Okay, when it's resulting vectors, you connect the beginning of the tip, at the beginning of the vector, all the way to where the end is. So now both the tips and both the tails are touching. So when it comes to just normal vectors, you want to do tip to tail. But when you're trying to find the resultant vector, that's the only time where you can do both the tips and both the tails of the arrow. But let me actually write that down to make it a little bit more understanding, okay? For just normal vectors, you want the tip to tail. Okay, tip to tail. And I'll put this right here. Okay, tip to tail. But when it comes to resulting vector, the resulting vector, that's the only time where I actually want oh, that's not good. Hold on. Okay, that's when I want the tip tip and tail tail. Okay. So basically, when you're trying to just make a little train with the normal vectors, you obviously want the tip to the tail, the tip to the tail, and the tip to the tail. But when you're trying to find the resulting vector, that's when you're basically trying to find that path. And that's the only time where you can actually do the tips and the tails, okay? We're going to do some examples real quick so you can actually know what the heck I'm talking about. But just keep those in mind, okay? A couple more seconds for that, and then we'll do some examples. Awesome. Is an example? This is an example of resultant vectors, okay? Okay, let's do some examples. Let's say I have let's start with just two vectors, right? Let's just start with two normal vectors. Let's do this one, and then let's do this one, right? So you can see I have the tip to the tail, right? That's how I want them. Now, if I want to find the resulting vector, all I got to do is just find that last path where I started from. I started off at this point, and I ended at this point. Okay. Let's do another one. Let's do another one. Let's say I have a path like this. Okay. And then I have another path like this. Okay. And I have one more path. Let's do one more vector. Let's do another vector that goes like this. Okay. Once again, tip to tail and tip to tail. What's the resulting vector? Well, I started right here at the end. And then I finish at right here. So all I got to do is just connect those two ones and boom, there's my resulting vector right there. I bet it should be resulting vector. Okay. Let's do one more. Let's say we do one that's looking like this. Let's say it goes down one. And then let's say it goes this way. And let's say it goes this way. And then let's say the last one goes this way. Once again, tip to tail, tip to tail, tip to tail, and then we got a tip, right? Now, if I want the resulting vector, I start off right here, and I end it right here. So look at that. My resulting vector is right there. And that's it. The black lines, the black arrows are the resulting vectors. So you always want to find that path from beginning to end. Beginning to end. Okay, let's go into our actual practice. So if we go back here, here's the conclusion. I think I concluded for you. If you go down to guided practice, there is a link where it says use the link below to go to Zeitboard. And the Zeitboard basically means it's a board where everyone can do work in one screen. So let's click on that. And the screen, you know, it's a Zipboard, and the screen should look like this. Oh, it seems like some people already used it. Interesting. So we should be right here, and hopefully more of my scholars will join in. So if you're there, you should join in. It does show, yes, it shows you're in. Yes, it shows everyone's in. Yes. So let's do, so basically this Zipboard, we'll get to use it more often just so I can see everyone's work. If you click the L and the A key twice at the same time, and then you drag, click and drag it, you should be able to make an arrow. I don't know why it's not there. There you go. See, there you go. See, now you're making arrows. See? So it was just A. My bad. It was just A. Oh no, it's L and A key. That's basically what they are. I'm gonna erase them. Okay. So if you click the L and the A key twice, it should let you do arrows. Okay. So for the assignments, let's make the resulting vector. Let's actually do the resulting vector on these problems. Okay. So we have right here, we have this example, we have this example. We have about 6 examples, okay? Let's make the resulting vector based on these examples. Awesome. So it looks a little bit funky because we're just using this for the first time. However, I will say that we will be using this more often. I think it's a really fun tool. So find the resulting vector. So we have an example right here. Here, can I use my, hold up. I think I can use my, oh, I thought I had a laser pointer, but it's okay. I have a laser pointer. So we have this right here. We have the result. The black one is the resulting vector. So this first one looks pretty great. The second one looks really great. We got tip to tail, tip to tail. Awesome. And then this one right here, the resulting vector. That's good. Now these ones on the bottom, they're a little bit funky because look at them. They're not from tip to tail. Do you see that? Some are, like this blue one is from tip to tail with the black one, but this red one, this blue one are not from tip to tail. So you actually need to rearrange it in order to make sure that they're all from tip to tail. So on the, look at this example right here on the left. This one right here, let me circle it. This one right here, as you can see, I rearranged these ones so I can move them to tip to tail. So I moved this one right here, and I moved this black one right here. And let me erase that again. See? So you see that? I just rearranged them. So by rearranging them, now these ones are no longer factual, so we won't use these anymore. But now look at that. Now it's from tip to tail, tip to tail, tip to tail. So what can I do at the end? Well, I can actually complete my resulting vector, and it's going to look like that. So that's how you should do with the other ones. I see some people are making that, are fixing that right now. That's good. If you click on the pencil, you can change colors. Red, right now it's only red, blue, and black because we have the basic edition. We don't have the pro edition. So, but yes, these are some examples we'll be using. So it looks really cool. If you're watching this and you already see some stuff here, that's because my Zoom Sync students already did it. So if you want, you can make your own. You can do your own one if you want. You know, you can like make your own one. You can make your own example, like, you know. You know, and then you can just create the resultant vector by doing this. Oh, my bad. Oh, no. There you go. Just like that. They're not super straight arrows, but you get the point. Awesome. So that is so that's all I have for you guys for today. Make sure for your assignment you do the post, the Think Pair Share post on Piazza. So make sure you click on the Think Pair Share post. It will take you here. Oh, it will take you here, and make sure you answer the question. Okay. And that's what I have for my Zoom for my async students. I'm about to head off. So goodbye to my async students. Hopefully you enjoyed this video. Goodbye.